And let's get into something probably may have not seen in Math 61. It's this whole concept of a function. I gave the first example. This is coming from the textbook itself. Sorry guys, I hear a little bit of talking here. First example comes from earning $7.50 per hour working. Let's say you worked 0 hours. And this one's almost like it's a rule. It's a rule takes you from hours worked to what your pay should be. That's before taxes. After taxes, a whole bunch less. All right, so plugging in a 0 into here. 0 times $3.50 gives you still 0. Good there? If you work 10 hours, you should expect to get $75. So this whole concept of graphing, what we're really doing is we're setting up a function. Setting up a function takes you from one set of numbers, like hours worked, to another set of numbers, in this case, payment. Or pay per a certain period. Okay, so if that person worked 40 hours a full week, then they should have payment of $300. You can also represent this as a graph. I also want you guys to show you a few little differences. Notice that these guys don't have arrows at the end anymore. Notice it starts at 0, 0. That's exactly where it starts. There's no arrow that goes beyond that because it really doesn't make sense to work negative hours. And then if you only can work 40 hours and there's no overtime whatsoever, that means you can't really go beyond this. So in this case, it has to stop right here as well. So notice this case, we're gonna talk about this whole concept of domain. How many numbers can I put? Does my graph actually need a arrow or not? So that's what we're gonna sort of deal with a little bit here. All right. So what we just did. Whenever you talk about the numbers you're going to plug in, we call those the domain. So in the previous example is the number of hours worked. And then there's kind of this little rule, and it gives you the output of all that stuff. That would be, in this case, it would be payment. And that's how we sort of graph a few things here. That's what we sometimes call it even the function maps. Let's just go to the example here. So you can go like this. Domain is on this side. 10 goes to 75, 20 goes to 150. But here's what you want. You want this little X right here. And as you get this, here's your little rule. It's $7.50 as the rule for each X. All right. Whatever you plug in is called the domain. Whatever you get as an output, we call that the range. So let's do this. So let's change it up just a little bit here for our example. What happens if you earn $8 an hour? Can you graph for me a graph that gives you $8 an hour? And again, you can only work from 0 to 40 hours. And we're going to use this example a little bit more as well here. But let's graph it here. So at 10 hours, all right, let's see, let's go back here. Let's make a little table, I guess. 0, 10, 20, 30, maybe 40 all the way at the end, just to give us a few little numbers to work with here. So 0 maps to 0, of course. 10 goes to 80, then 160, then 240, and then eventually you should get 320. And then we'll start plotting them here. So 10 goes to 80, so a little bit underneath 100. At 20, it's a little bit more than halfway between 100 and 200, just a little slightly more than halfway. 30 is going to be a little bit less than halfway to 300 from 200. And then at the end, a little bit above 300. And notice what I'll do is I'll just kind of combine them together. Alright, you got also other math textbooks. What they'll do is they'll put like a filled in little dot right here. Kind of makes it just a little bit bigger just to make sure, yes, for sure I know that that stops right there. And they'll make a little bigger dot at 0, 0. Therefore, everybody sort of knows that I took the extra time to fill it in just a little bit more just to make sure it stops there. Okay, but let's go just a little bit more abstract though. So, our domain here, our domain is going to be the numbers worked, right? The range would be the pay that we get. So before we get there though, let's talk about, in general, let's talk about this whole concept of domain. Again, don't need to write it down if you don't want to. Alright, whenever we talk about a function, or whenever we talk about coordinates or points, the first number here, the 2, the 6, and the 12, that is going to be always our domain. And the last numbers, or the y values, those are always going to be our range. So whatever you plug in, because x values are the ones that we plug in always. The y values are the stuff we get out. So let me go back just real quick to the previous slide, just so we know. So on the bottom here, this is what we plugged in. We plugged in the 0, the 10, 20, 30, or 40. And then we got an output of whatever the range was. So notice these are the x values. That's the x axis. This is the y axis. So in terms of that, let's go to question number 2. So for this particular problem, can you give me the domain and the range? And again, could be tough here. Wait for me, we'll do it. If you think you got it, go for it. Because remember, the person could also work 11 hours, right? Not necessarily 10 or 20. It could be 11. It could be 11.2 hours. So this is not really discrete or individual points at 10. This is actually continuous. It goes from 0 and goes all the way up to 40. So that we write. So domain would be, we got something called set notation on our hands here. The set of all x such that, and then what we do is we put a little condition on here. That x has to be a number between 0 and 40. So yeah, the person can work 12.5 hours, and that'll be fine, because it's the number between 0 and 40. The person cannot work 45 hours. Okay, so let's see, range would be now all the y values. And what is the range for y? What's the lowest the person can get paid? 0, right? Because he worked 0 hours. What's the highest? It was 320, right? It was the highest we had on our graph, right, for 40 hours. So that means the payment will have to be between 0 and 320. Can you guys write that down? Alright, here's what I got. 0 is less than or equal to y, because that's our variable. Y is the variable here. And the maximum it could be is 320. And again, introducing you to something called set notation. Set notation is you declare what your variable is, and then you got this big bar line. This bar line means such that, or based upon the condition. And then here's your condition. Okay, let's do a few more things here with this whole concept of function. Let's go with tossing a softball into the air. And let's not do linear stuff, let's do something different here. So Kendra tosses a softball into the air so that the distance h, the ball is above her hand. In terms of seconds after she begins the toss, is given by 48t minus 16t squared. And our domain is, we're just going to look at from 0 to 3 seconds. Alright, what I also want you guys to notice, remember how we had y equals something? Notice from here on out, look at this, I got h is equal to something. So we have equations in terms of a certain rule. And that's why y equals mx plus b is so important, because that mx plus b gives you that rule. Okay, it's all yours here. Can you plug in a 0 into that? Alright, so at 0 seconds, right at the point of release, it's still going to be 0, because they're both at the same spot. So what happens 1 second later? I heard 32, yep, I think so. 48 times 1, subtract 16. After you square with 1, that's okay, it's still going to be 32. So 32 feet up in the air. Ooh, how fun. 1.5. Love it, love it. You plug in a 1.5 into that. Alright, plug it into 1.5. I agree with 36. Alright, plug it in a 2.
$32.
32 is good, yep. Alright, and what happens at 3? Yep, and we got a couple of people saying the same thing here. Yep, it went back down, or 0. And there's my 0. Hopefully she caught it. Hopefully it didn't hit her head. Alright, so this whole concept here is the whole concept of just a rule. This gives you the height. It's equal to some kind of rule that makes sense of the world around it.
On the 1.5, you got 36?
36? Yeah. Alright, and now the question is, can you graph it on the graph there? Alright, the graphing should not be that bad here. So at 0, you get a 0. At 1, go up to 32. Then it goes up to 36 at 1.5. Back down to 32 at 2, and then back down to 0 here. How are we going to graph it? We're not going to put arrows. We're going to just go up, come back down. If you want to emphasize the fact that it ends, you could put a little bit bigger dots right here at the end at 0, 0 and at 3, 0. Alright, but let's take a look at this other concept here. If this is a function, and a function relates something like in real life, and Kendra throws up a ball, can the ball be at exactly 1 second? Can the ball be at 32 feet high at the same time 40 feet high? So Kendra throws up the ball. Can it be at 2 places at once? No. Okay, so here's what we learn about functions. If you have a function, and function defines something real, that object can only be at one place at one time. And so if you had somehow a 1 that's associated with 32 and 1 that also goes up to 40, we know that's no longer a function. It doesn't represent something real, something correct. So now the question is this: can you graph for me this set of numbers and tell me if it is a function or not?
Is that the only thing that determines a function, is if they're in the same spot at the same time? So if they're scattered all over the place, but they're not in the same spot at the same time, it's can be considered a function?
Let's get through the next 2 slides and you'll be clarified on that. Alright, most of you guys are done here. So let's go for it. So 1 goes to 5, 2 goes to 4, 4 goes to 8, 2 goes to 9, 5 goes to 10, 6 goes to 12. And what's our problem? I think it's the 2's right here. Right? 2 can go to 4, then also 2 go to 9. So let's think of 2 definitions here. So if you have a graph, the problem comes in is when you have the same x coordinate going to sort of 2 different y coordinates. That's our problem. So if you go over here, actually we can use the same definition. If I have this 2, 2 goes to a 4, and then I have the 2 again, then that 2 goes to a 9. Notice it goes to different x coordinates, so no, this is not a function, first of all. Alright, if we say what's the problem? The problem is that x equals 2 goes to a y equals 4 and a y equals 9. It goes to 2 different spots. And you'll also see this word called relation. Relation is just any numbers that go together. So this is called a relation, but this is not a function. Any kind of graph, any kind of x and y coordinates would call a relation. It's grouping one number to another number. But it does not necessarily mean that it's a function. It doesn't represent something tangibly real in real life. Okay, so next question is, it's just the individual points? Yes, but if you have a graph, then with the graph, we got to make sure that the graph itself is a function. And what we do is we think about something called a vertical line test. If we had a straight line, a line going straight down like this, the question is, at Each of these individual points does it cross at most one spot. There could be no graph there at all. That would be okay too. Or it crosses at one spot, but it should not cross at more than one spot. So this little parabola here, is this guy a function? How about the absolute value? Yeah, we call absolute value function. How about a linear function? Absolutely. How about this guy? Now, once you get to about right here, you got yourself a little problem. This is still okay here. No function is still okay. But at 0, right at x equals 0, it's still okay because they combine together. But once you move off just a little bit to the right of that 0, then you're in trouble because now you had 2 points that it's hitting. And at that point, it's not relating something true anymore.
Because they're both on the same line.
Say again?
They're both like one at 1 and one at -1. Because of the problem.
Yeah, because if I were to put in a straight vertical line going down, I'd hit this in 1. Okay, so the next one. Alright, as I plug in -3 in for the y value, that'll be 9. 9 minus 4 would be a 5. Everybody good there? As I plug in -2 in for the y value, that'll be -2 squared is a 4. 4 subtract 4 is 0. Plug in -1. -1, that'll be 1. 1 subtract 4 is a -3. Plug in a 0, that's easy. That's going to stay as a -4. Then means 1 positive 1 plugged in gives you -3. Positive 2 gives you a 0. And then 3 squared is 9. 9 minus 4 is a 5. And can you plot those? Kind of careful, me, because this is not the x, this is the y. So they're sort of in reverse order. So if you want to, maybe write them correctly here. So 5 comma -3. 0, -2. -3, -1. -4, 0. -3, positive 1 this time. 0, 2. And then how about 5 comma 3? After you plot them and graph them, can you tell me if it is a function? Alright, some of you guys are already finished here. 5, -3. 0, -2. Then goes on to -3, -1. Goes to 0. Then above the x-axis would go like this. As you graph them, have to sort of be graphed out to the right. And we say not a function, right? It's going to cross this at more than one spot as soon as you go past -4. And one more here. Let's do the same thing here with another one. This one doesn't tell you which numbers to plug in, so you got to plug in as many numbers as you need in order to get a nice solid graph on your hands here. So you got an absolute value of x minus 3. So make a little chart if you need to. If you can't do it in your head, that's fine too. I started off with -3. You guys could start off whichever number you want, but eventually we should have the same exact graph, and then based upon the graph, got to see if it is a function or not. I got a couple of people already finished here. Yeah, they're still doing this. So let me plug in the numbers. Those of you that are done can check. That's what I got so far. At the same time, I know it keeps on going on both sides, right? It doesn't just sort of stop at -3. So we got to think about, okay, does it stop or does it still keep on going? It keeps on going. The arrow means it still keeps on going. There's no restriction upon our domain. And there's no restriction upon domain the other way. So then the question is this a function? Sure, it only crosses at most once. Cool. All right, I think that point will stop.